The Gibsonette visits us again. I can't get rid of this guy. Complaints that absolutely nothing was coming out. I hooked it up again. Same procedure as usual. Did have stuff coming out. Of course, when I used my generator. However, I knew it wasn't right. And looking through here, I immediately see, I look at some plate voltages. I see some drops that tell me that they should not be there. Significant voltage drops that don't allow. And I see right here that this resistor has had a significant increase in resistance since last, according to my notes, climbed up a large amount. This has had an effect on the next resistor in line. It sits behind this capacitor. We can't see it. That in turn affects this 12AX7. The performance of this 12AX7 was displayed on the oscilloscope. We see that it's working, but to a much lesser extent. That in fact is pulling down the rest of this amplifier here. What's happening here is this was restored in a manner originally to get it back working again, you know, and ever since then it was driven hard and put away wet. What we're seeing is a lot of these original components are starting to fail, and they're failing one by one. You'll remember this capacitor here started to fail. We've seen another capacitor. We saw that that solder joint that started to get loose. That was not caused by the amplifier running, of course, but you know, instead of sitting there in a corner for 30 years, it got picked up, put down, moved around, dropped, and what have you, and the solder joint came loose. You know, I replaced the inside of the light fixture. That just happened, you know, from shaking and whatnot and vibration. And these resistors they're starting to go. The joints are starting to go. I went and turned this thing over and got inside these sockets, and I was able to retweak them. You know, I got the tube sockets nice and tweaked now. These three, the 12AX7 is not necessary. The 12AX7 sockets in perfect condition, of course. A lot of noticed a lot of accumulation of the little metal shards that grow on the electromagnet, little stalactites. Always very dangerous when they accumulate around the tube socket. So I take care to notice those things as well. What do you do? We're gonna have to go now and say that this amplifier has been at least sufficiently burned in to the point where somebody was able to sufficiently break it, right? So we're going to have to look at this as an amplifier that was brought to me as suspect, and as such I'm going to have to now look at all these resistors again. Not overly concerned with the capacitors, at least not on this side, you know, and look at the power supply, should be fine, and see which ones have climbed, see which ones are falling out of tolerance. Make sure that the capacitors that are used for the 12AX7 for biasing are still good. Look at these capacitors, obviously crossing the 6v6s that make up these bias components are okay, and measure those accordingly. But obviously I could easily measure those by looking at how many milliamps are coming across these. If it hasn't changed at idle, I know that that circuitry is still okay, right? So I'm not going to get too deeply involved into that, right? And we'll see how that's going, and make sure that after all this work is done, that none of this is getting loose or ripped up or whatnot mechanically, because mechanically is something I've been overlooking after, you know, all this time, with somebody starting to lift up the case and move it around and walk it around and do whatever they do with an amplifier, you know, in the course of using it. So that's what I got. We'll see what happens. All of the resistors that are used for voltage dropping throughout the amp have been replaced, except for this 500 down here, which is absolutely perfect even under load and testing. You can't see it's behind that 10 microfarad cap. That one's just fine, and it brings it to voltage levels that I need. It doesn't get incredibly hot. I went and tested that further than the others to make sure that that was really good. This 200 is part of a cathode bias, and that one is perfectly set for what I need, so I didn't want to do anything with it. All the others gone, ripped out, not remaining, and the voltages are looking good right now. Just to see right here, as we get it, we'll just go right to the end here. and come off this 12AX7. And this could be on the loud side because this is on the post amp here, but I see 160 with the AC on, we're getting 153. So we got all the voltages right back where we needed. This was down around 100. We see 153. We'll come off the other side. This is the pre, and that's also 153. So it's looking good, and that's coming off now. This one here is 274 according to the schematic. After that side right there, 237. Schematic shows we should be seeing, I'm sorry, try to 240, right? There's the 22, 240, 237. So everything's looking pretty good on this amp now. I think this resistor swap out was a success, and this amp needed it as it was getting used again. These resistors, these voltage dropping resistors, are getting really tired. So now we're going to hook up the all the fun test equipment again, make sure everything's working real good. We'll slap this back in the amplifier, give it a test, and send it back off. All the resistors have been replaced now, except for the those high wattage ones in the sand coated ones there. I've got the oscilloscope set up now, feeding in 800 hertz. The oscilloscope is connected to the 12AX7 inputs. You got the preamplifier and post amplifier right here. You can see the preamplifier waveform. And there's the post amplifier through the tone control. Here's that. Here's the tone control, adjusted volume. Everything looks good. That is not the output. You're hearing the output, but you're not seeing the output. This is just 12AX7. So you can see that they're clipped right here onto the 12AX7. And we can see my cell phone going through there as well. Now I'm going to take a look at the finals here on the 6v6s. Now we have it set up where the yellow is showing the output on the finals. It's connected to the 6v6. It looks smaller, but the yellow is actually 20 volts per division. Where the blue is 200 millivolts per division, so it's quite an amplification. Having put the amp back into the chassis, I made an immediate observation when I turned it back on that it was not producing any sound as I would have expected it to. There was audible sound coming out, but not nearly what I wanted. I hooked the oscilloscope up, checked all the levels as far as the 12AX7 goes, and then looked what was coming off the finals. And that's when I had noticed what became apparent, something that I had already expressed when I heard the amp on site, was that the coil in the speaker had failed. It was already sounding like it was starting to fail, but it was in fact failing. Generally, when I work on these amplifiers, as most people know, the cabinet and the front of the cabinet is very delicate, so you get these out of here as quick as you can. You hook it up to an alternate speaker, and you do your work, and then you put it back in the cabinet, right? So when you do all your testing, you're not testing it with the actual speaker. And in doing so, obviously, I noticed that when hooking it back to the original speaker was bad. Hook it up to other speakers of matched impedance, obviously, and the amp works fine. Leads back to the speaker, and then when you start testing the speaker, obviously with different equipment, you notice that the speaker itself is bad. So worked around the speaker to show that the amp, in fact, is good now, with the correct voltages, of course, and it's going to require a speaker replacement. So that takes us to a whole different type of business here, because now we're not talking about the amplifier work anymore. We're talking about replacing the speaker in the cabinet now. So that's where we're at. So the repair on the with regard to replacing the resistors to get the voltages correct is done. It sounds good through my old Radio Shack speaker of equal impedance. However, as for the cabinet, this Jensen speaker is not cutting it anymore. Probably shouldn't have been run at such high volumes since it's, 60 years old, but, it's not my amplifier. So this is what we got. Probably a bad speaker coil, broken speaker coil. You could barely hear it. If you tap on it, you get a little sound out of it, but that's all there is to it. I've hooked it up to the old speaker so we could listen to what it sounds like. I'm gonna strum the guitar and bring the phone nice and close. I'll turn up the volume. That's basically what we're getting here. Now I'm going to hook these alligator clips up to the Radio Shack here and repeat. So now we're hooked up to the Radio Shack. I've reduced the volume because I don't feel like blowing up my own speaker. But the only thing I've modified here is obviously the connection to this amp. And now we're connected up there. Got my tone. Is working fine. Volume, like I said, I've limited. Seems about safe right up to that part right there. Has that nice harmonic it used to have before it broke. It's back in there. Obviously I'm just hitting the guitar here, not strumming any particular chords. All the voltages are correct now. So this is pretty much done. It just requires a new speaker at this point. So seems like the output transformer, the audio transformer is okay. It's in fact the speaker itself. So. And I'll admit that my Radio Shack speaker is not like the highest quality speaker on the planet, so it's not going to sound absolutely fantastic, and it's pointing towards the wall. So. Full treble. So yeah, this is about how the amp sounded the first time I restored it and everything was working fine, so I like that. So there we go. Thanks everybody for watching.